Hello, everybody. I hope that you had very exciting, insightful breakout sessions. My name is Marcos Lopez de Prado, and I will be your host. My objective is to let other people talk. So without further ado, I'm here surrounded by an excellent panel. We're going to learn a lot. And I would like to start with a question for all of them. We can follow our geometric positions in order to answer one question. So what I would like is that I ask this question and you spend maybe 30 seconds giving you your bullet points. And then after that, I will ask questions that are a bit more targeted to specific individuals. So my first question is, AI can help increase the efficiency in resource utilization, but it is also becoming a major energy consumer, thus compounding our sustainability problems. What is, in your view, the best use of AI towards sustainable development? Alex?
In my mind, we should use AI to design thermonuclear reactors which can provide unlimited, relatively harmful energy and sustain the AI in this virtuous closed loop.
Wonderful. Luis?
Accounting systems where we can account for the things that matter.
Very nice. Thomas?
I think we should apply it to all those sectors that contribute most to the environmental SDGs and redesign them.
Vivian?
I will say that purpose and focus, because I mean it's not it's not like you have a hammer and everything is a nail. So you have to have that perspective. Use it, also design it effectively and efficiently.
All right. So Young?
I think the model integration, because a lot of data or modeling, like fascinating modeling work is happening individually, but is there any way that we can integrate and a more efficient use of AI generated data? That's something that we want to think about. Thanks.
Wonderful. Joseph?
Yep, 3 big words: generative AI super sampling for connecting climate to weather prediction.
Of course.
And of course, climate risk analytics and all the fun stuff after that.
Of course. Wonderful. Very good. So now let me go a bit more into targeted questions. This one is for Soyan and for Luis. Financial markets have been developed to manage a wide range of risks. How are they being used to manage climate risks? And what are the problems with the current approaches? Luis?
The SEC just declared about a month or 2 months ago that carbon trades are derivatives. That, I think, is going to open up a whole new market. If interest rate, for example, was a risk that was mitigated with the arrival of swaps in the 80s, and that was like trillions of dollars of trades to remove risk, I think we're going to see something similar in financial markets now. I like to say that every era in human history has a commodity that defines the era. The commodity now is risk. It's the first time we have a commodity that you cannot touch, you cannot feel, you cannot smell, and it's risk. And when it comes to climate risk, it's going to be no exception. I think the creation of financial instruments that allow for risk mitigation, for risk transfer, and for risk profitability, I think that's what's coming.
So Young?
I think the realization of the risk and then risk of myself, because we've been talking, I think IPCC and COP and all those global discussion, we're doing great job that oh, okay, everyone is now know that temperature rise and so on, but unfortunately what's not happening is, okay, what happened to my specific asset? And then this one is the one biggest barriers that is making the investors are very slow in the financial market, really actively accessing and managing climate risks. So I think this is the realization of the climate risk is important. And then why I'm saying this, because this one means that you have to be able to do the granular analysis. Granular analysis meaning the asset level analysis. Before it was hard because many people were saying about we don't have data. But now that we can, have some, we can generate some data, but then, what else is missing? So this one is something that I actually talked in our parallel session, that we started actually surveying the room that, how many are on the climate modeling, and then how many are on the infrastructure engineering, and then how many are on the financial engineering. Because this morning we were talking a lot about the climate modeling, how can we get the accurate projection, and how higher resolution and so on. But this is very important. But the one that is largely missing puzzle is that what is actually happening in the infrastructure assets. If the temperature rise, how that actually work in the operation of my asset. Is it the production or efficiency, or what is it? This the impact mechanism is largely understudied. So this is the area that I think the machine learning can come in and then contribute. So once we are able to understand clearly what's happening in the climate modeling, infrastructure operation, and then the financial modeling, then what I just said, model integration could happen. Then in harmony, that we can be able to see, okay, if temperature rises, this is something that's gonna be happen to my asset in specific location, and then in what financial value it's gonna be realized as a, the mature term. So if we are able to tell this type of storyline, that will give the urgency to the financial market.
All right, very good. This one is for Alex, Vivian, and Thomas. Over the next 10 years, how can the digital economy help address the challenges of climate change? Alex?
Thank you, Marcos. It's a very interesting question. So in my mind, what I was talking about is that we can use artificial intelligence to optimize supply chain, and more generally sort of production process as a whole, and make it more streamlined, more resilient, more equitable, and at the same time for more closed loop, and not to be confused with the closed loop I was talking about earlier today, but mostly here what I mean is the ability to recycle goods. So basically there is much less waste which is left after the sort of start to finish process, and in fact start should become also finish, and then in general reducing waste, rationalizing payment systems, and generally making things better, more readily available, and as such, requiring less effort to less things to produce, because the things which we do produce would be better and longer lasting, and when they stop serving the purpose, they would just be recycled and repeated, like the Ouroboros I was talking about. But at the same time, what I also think is that in general, we can probably put more efforts into designing mechanisms which would assign value to efforts to fight climate change and general things like that. So for instance, this voluntary carbon markets, leave a lot to be desired. Perhaps we can invent something along these lines, but better suited to actual better suited to actual realities on the ground. And also this, lastly, the idea of Jonathan and Patrick about actually linking the other living being becoming part of the larger economy, not in the form of parts, which is sadly what's going on right now, but as other core inhabitants of the earth. That would also be quite powerful. And for that, as we were discussing, you need to come up with new, presumably digital financial incentives.
A lot to unpack. Very good. Next, Thomas.
Yeah, there's even more to unpack. So we made a long journey, right, from the Silk Road to really to the digital twins, and in between that, we discussed, for example, also potential application areas of green digital finance. So what is really in for the environment, and we discussed examples that make carbon emissions more transparent for the individual, for example, but also how to securitize nature capital. So there are ideas around why should an exchange rate, for example, for a certain currency not also be linked to the capital in nature that a country has. Brazil, for example, with its rainforest, should maybe have a higher or a better exchange rate to the US dollar, given that it has such a great nature there. So these were examples that we discussed, but ultimately, I would even say I would dream of like a Star Trek kind of cockpit, right? That you have where you can really identify all the financial flows and all the real economy flows, and then see where the risks are, where the potentials are, and then tap in with all these new tools that we have, right? So that was
wonderful. Vivian?
Well, being an IT consultant, I will tell you that, well, I will split the 10 years in different sprints using an agile, an agile philosophy, because I think we should start simple with what we have now, that is a lot, and already Alex showed you how much do we have to start with, and to bring up enough stakeholders to make a real transformation and build up upon that. Build up upon all the academic investigations that are already in place and build up on the actual technology. And in 2 years' time, maybe we can have another sprint, and maybe we have different problems and we solve them. So yes, I mean, like you said, we do the math and we just act upon it.
All right. This one is for Yusuf. Yusuf, you stand on your own. So this question is for you. Climate data offers a single path of realizations with very few independent observations. Under those circumstances, it is very difficult to estimate generalization errors. So how can we be confident that AI climate predictions are accurate?
That's a very loaded question with a lot of nuances to it. So the fundamental issue is trust. In the deep dive sessions, we saw a plethora of really the cornerstones of all these models is observational data. How do you define ground truth? Is it literally what you measure on the ground? Is it what we're looking at from space, from all the remote sensing products and weather satellites we have? Or is it somewhere in between with the thermodynamic structure that we're measuring with weather balloons and whatnot? So really it comes down to how do we come to reconcile a unanimous definition of trust when that comes. And that, of course, depends on the applications. Are you looking at a local community scale? Are you looking at a country level? So back to my initial comment on generative AI supersampling, that will unlock, obviously, a new understanding for trust, which is well balanced in the sense that you're looking at it on a local scale. So, yeah.
Wonderful. All right. Let me ask you now questions, and please, anybody who feels interested in picking the question, just go ahead. My first question would be, through these sessions, we have learned a lot about new AI models, approaches, and also applications. Now, there is a lot of hype as it relates to AI, and it sounds like it's going to be a solution for everything. In your view, what are truly realistic applications of AI towards sustainability and towards reducing the impact of climate change? What can we realistically expect over the next 10 years without hype, based on evidence already present today?
I can try. I think there's a lot of lack of information when it comes to climate issues, whether it's financial, physical, impact on infrastructures, all of that. And AI as a educational tool, I think will be very interesting and perhaps not mentioned enough to teach people so they can learn what that's all about. That's one of the biggest, in my opinion, one of the biggest challenges when it comes to sustainability is education, for people to understand what that really means. AI could be useful for that.
Shall we go to the next question, or any other volunteer?
I need someone to disagree with me.
I do. I would stress another point to that, in addition to what you said. We have many, I think on a macro level, there are many inefficiencies that we can still see. So optimizing that. So we've heard many examples, like from Steve, with the energy grid and things like that. I think AI can help us with that. I think that is one thing. And the other thing is not the macro, but the really on the micro level, to go deeper into certain things. So the weather prediction that we heard, for example. So to go really on a very fine granular level and to analyze that in more detail. Ultimately, that also needs to optimization, but I think you can do both with it, right? So.
Well, then you don't disagree with me.
No,
oh,
that's
okay.
what no. I totally agree.
Then you disagree with me.
Not really. Well, I don't think so. No, but my point will be that it also needs to see, we need to approach that in a more vertical way. Because if we approach it in a horizontal way, that is right now, I mean, everybody uses Gen AI for about everything, there's a lot of waste. If we really get to think in actual problems, in actual frictions, and go it vertically, we might have a chance to wait for efficiency, for all the models, for all the technology, for really carbon footprint improvement, while addressing the same issues. I will give you an example. Right now, we have a use case about financial inclusion, and there's 35% of people in the United States use Gen AI to ask them about their retirement and their pension plans, and it gives generic questions, but why don't banks or other financial services institutions provide financial inclusion by using AI as a natural language provider, but they have a lot of information to really generate valuable insights. And actually, we are trying to test that. And we limit the usage of questions using RIG implementation. So we use Gen AI in a more efficient model for the same purpose of asking about our retirement.
All right, very good. Now, there is this mantra that we have all heard many, many times, that AI allows us to extract actionable information, or put in other words, AI lets data speak for itself. Would you agree, disagree with that statement? Does data speak for itself thanks to AI, or even without AI?
Well, it depends on the data, right? So, I mean, some data does and some data doesn't. In my mind, I think data related to, true behavior of the financial markets is not really very susceptible, precisely for the reasons which you were discussing in your presentation yesterday, that lack of causality and false regressions and things like that, even though if they might be much more complicated than simple linear regression, but still the spirit of not knowing what is the cause and what is the outcome, right? So that kind of prevents it. But some other things, like, for example, consumer behavior, or viral distribution of information on TikTok and things like that, that is perfectly susceptible to that. And in fact, it's governed by that already.
Let me clarify, and I agree with everything you said, but let me clarify, in the context of climate data and in the context of sustainability, does data speak for itself? Is this a field of domain where we can just utilize essentially what it is, a forecasting tool to answer our questions?
Very hard. In my mind, some of it can be, simple things like recycling, and then again, calculating honestly what is cheaper to throw away to recycle, because recycling itself has a carbon footprint which might be not insignificant. As far as climate modeling is concerned, I would say there are too many unknowns, and it's not a coincidence that when, for example, Steve was showing all these graphs, they have very wide confidence intervals, just because, for the reasons which we already heard from Zurich, right? So that you need to go to such high resolution that it becomes impractical. It's basically, we are living through a cycle, when information goes deeper and deeper, but at some point has to stop just because it's simply too deep. Like, let me remind you that during the Second World War, there was struggles upon struggles over actually having weather stations where they were not there, right? So, and the only case when the famous Tirpitz actually fired the guns in anger was when they tried to destroy a weather station on the Svalbard Island, right? So that's an attempt to make things granular, and that is something which we can do. But going below like a few 100-meter resolution is probably outside of current capabilities of the artificial intelligence, and it's going to stay this way for several years to come.
I think there is another example from another domain which would also help. If you look into drug discovery and understanding our human body, it turns out that until that moment, we don't really yet understand how our human body really works, right? And up to the moment that we know that, then I think the data could help us. But now you could measure, right? You could measure your blood, you could measure temperature and things like that. But what would you do, right? If you don't know how to use it then. I think that can also be applied to climate, and we've heard a lot of examples here about streams and winds and things like that. We don't really fully understand it, right? And I think if we do that, I think it would be more easy then to use that data. So the complexity is still high.
So for years, I've been studying the corporate communication data about sustainability. You know, when companies are talking about their performance on environmental impact or decarbonization or ESG more general and so on. But depending on the source of data, I think I think the credibility and the reliability of the data is is pretty diverse. So, and then, you know, it's not consistent. This is what I have figured from years of research looking into those the corporate data. So you know, like these days what we are doing is, you know, like it depends on the source of data and then how we intervene this source of data. Like for example, simply whether this data source is actually coming from the mandatory report versus voluntary report, how that actually contribute to the reliability of the data that we are getting out of it. That type of thing is it's very interesting. So I think when you're looking at the data, I think as of the current status, you know, like the source of data is very important. And then so when we are using this corporate data for the financial insight, what we are doing is, you know, like we are actually validating that with other indicator that is not coming from the self-communication, but you can actually cross-validate from the fact. But what is hard about the sustainability is, you know, like there's no absolute truth. So, you know, if there's an absolute truth, you know, you just go and then measure that thing and then use it. But, you know, it's a very complicated issue. Like you have to infer from many different sources of, including the self-communicated data. So that is all built towards, you know, like a true sustainability picture of the company. So that's a long story about the source of the data. And then the second part, I like your question about whether the data giving the insight immediately. I don't think so. In terms of the application perspective, because it also requires a domain specificity, like how this data is being used, and then, you know, like the insight that you can seek out of the same data could be very different. Like even today we were talking about climate-related financial risks, and then, you know, like even this, you know, like when we are talking about asset owners, you know, I was talking to ADIA, Mujib were talking about who is a direct user of this thing. If it's an asset owner, insurance companies, utilities, and, you know, depends on the which, you know, stakeholder is using that data, the insight could be different. So, you know, in order to do that, I think, you know, you have to include the domain knowledge to it. Now that, you know, like we know the variation that is coming from the different source of data and then also the usage of the data, then when we are thinking about the validation of the data, we have to think about, you know, how can the validation process can address this variation. So not only the, you know, like this computation is frequent or accurate or something, but, you know, like validation can be also focusing on the, you know, like the user insight and so on. Yeah.
Yep. As a climate scientist, the way I interpret the question is, are these AI-based weather forecast or climate models learning the physics? The short answer is preliminary results do show that they are learning the physics. Are they learning the physics well enough to replace altogether the physics-based models? Or should maybe a hybrid approach be applied where we replace certain costly parameterizations in these physics-based models with AI-driven approaches. So, you know, where is it? It's a matter of, do you put your eggs in one basket or you distribute, right? We need to keep on making advances in purely AI-driven global weather forecasts, but also look at hybrid approaches where we keep evolving the physics-based approaches, but focus on really the costly parameterizations, so in terms of cloud scale parameterizations to focus AI in those targeted areas. So I see it more of a hybrid approach that would be more of a win-win.
Yeah. So may I add something to that? So in fact, I have to say some of the interesting developments of the last couple of years was that people figured out how to solve partial differential equations by using artificial intelligence rather than finite grids or finite elements. That is actually quite promising. In some sense, some of the problems related to previous attempts to model the weather and then the climate is that people will quash the three-dimensional equations for the flow of fluid within the ocean to the two-dimensional parts by averaging out the height dimension. But now we can afford actually to solve the Navier-Stokes with maybe additional components in its full 3D fury and glory, and from that perspective, doing so by using AI methods, it's to complement what Yusef just said. I think that is promising in my mind, and it can be used in other areas as well, just generally augmenting finite differences and finite elements with AI solutions. Quite remarkable development, by the way.
Very good.
So, Marcos, so your question was if AI will let data speak for itself. So I think the answer is yes, it will speak. What is not clear is we will understand what it says. That's the part. And I think I'm summarizing what people are saying here.
All right. Now, let me follow up with Joseph's argument, whether AI is learning physics well enough. And there have been situations where AI learned physics extraordinarily well. For instance, I recall a paper from 2018 by the University of Maryland, where researchers were able to utilize various machine learning techniques to predict the spread of wildfires to multiple Lyapunov cycles. So Lyapunov cycle is a way of measuring how many iterations of a chaotic system have occurred. And it was unheard, the possibility that these systems could predict the evolution of these fires so far into the future. So that's something that can only be done with these sort of techniques, not even with numerical methods or some other approach. This was truly a breakthrough that occurred in, as I said, in 2018. Now, in that case, we are talking about learning something for which many occurrences have happened. Wildfires occur thousands of times around the world every year. So in that case, yes, there is a ground truth that we can use to assess whether truly these methods are doing a good job. Now, in the case of climate change, we have only had one historical record that goes back to millions of years, and that's it. It's one path. So how can we make sure that they are actually learning the physics of climate change and not something else? We will know, I guess, eventually whether this one path will be the predicted one, but even that will be a very poor assessment, because what we need is 1 million planet Earths where all of these chaotic systems have evolved differently, and then we would need to average over these 1 million planets to see whether the algorithm has done a good job. So will we ever know whether these systems got it right by chance or got it wrong by chance?
This is a very interesting question, Marcus. I have been thinking about the Lyapunov exponents in conjunction with GPT-3 in particular, because I start to think that GPT-4 is working on a different principle, but GPT-3 was showing the ability to build things token by token with remarkably low Lyapunov exponent. I think I need to disagree with you respectfully as far as prediction of sort of trajectories with Lyapunov exponents, because it's only possible if actual Lyapunov exponents are small. Because if they're just big, you cannot predict it anyway, right? So if it's, say, order unity, then you cannot advance it for 10 years, for say 10, but so, and you said yourself, there is a repetition of this kind of rhythm of this wildfires and so on and so forth. Make no mistake, what you're talking about is a remarkable thing, but you know, like in my mind, if Lyapunov exponent is big, it's actually big, and it's sort of whether you have a fixed point or a fixed trajectory or some strange attractor, you know, if it's big, it will go somewhere else. And your question about whether or not we actually observe a single trajectory is a very deep one. And my feeling personally is that, yeah, we observe a single trajectory. We can be right by chance. We can be wrong by chance. And we will never know, right? So the same with the market, right? So you will never know who is a truly great investor who is engaged in, unless it's a repeated sort of customer, you know.
Now, I would make the distinction that in the case of climate is even worse than with markets, because with markets you can make some assumptions that events that have occurred, let's say, 10 years apart are sufficiently distant that they are not truly influencing each other. But in the case of climate, this is truly a chaotic system that has evolved. For those of you who are not familiar with this concept of Lyapunov times, essentially what it says is that given two chaotic systems that start with essentially the same conditions, perhaps with a very small negligible difference, at what point in time they diverge. And what this algorithm from Maryland was able to do was to make predictions over 8 Lyapunov times, which is unheard. So it appears that in some cases, AI can learn to predict chaotic systems through even what we might consider the distant future for a chaotic system. But as Alex has just said, this may be a very specific case where something about the chaotics of wildfires makes it predictable, not necessarily in a system as complex as climate. So that's my preamble for Joseph.
Yeah, and I think to take it a step further, I agree with you, it's learning physics. To what extent? That's what I think we were disagreeing on. And then is it generalizable? So, okay, it's learning the physics based on the training data that we've been providing it from physics-based models, right? So in case of climate models, all these recently released AI-driven models from Google and NVIDIA, they're all trained on physics-based ECMWF physics-based models. So the question is, you know, they're trained on a certain warming scenario for the climate over the past decades. What that looks like in the future, nobody knows. What we saw in Steve's presentation, it's expected to be at 3 degrees Celsius. How confident are we with that? And it's a very chaotic system, as you said. There's a lot of non-linearities in the physics itself. So is the model able to generalize the physics it learned on the past for the future? I think that's the key question, which I've yet to see addressed, of course, with the recent release of these models just in the past 2 years.
Maybe a very quick provocative question with an answer of 10 seconds. Are there any models that predict that if we continue doing what we are doing, climate might actually cool?
I'll use the IPCC reports as my as my reference, and the short answer is no.
All right, very, very fair. All right, let's open the question to the public. Please raise your hand. We have a young gentleman who is going to impress us all.
Hello there, my name is Mohammed Ahmed and I'm a 14-year-old. My question involves the prediction of major climate events. Earlier during the breakout rooms, in breakout room C, they were presenting about how AI could predict some weather events, like cyclones and currents. So, could AI possibly predict about how the melting polar ice caps would affect ocean currents and coral bleaching in regions like the UAE?
Excellent question.
I was lucky enough to have him in my breakout session, so that's a great follow-up question. So the short answer is yes. For the things you're asking about, those are in the order of what AI-driven models currently resolve weather at. So 25 kilometers is what the best data-driven models out there are currently looking at. So for those types of applications, you can certainly look at that for sure. And people are already doing that. Happy to share papers with you, and we can discuss.
Wonderful. Another question?
Thank you. What happened to good old-fashioned mathematics, statistics, and computation? What I teach machine learning at Queen Mary, University of London, and other places, and I teach my students the basics. I teach a postgraduate level. I expect them to have most of the basics, but I just remind them. And basically, if you understand the basics, you're less likely to be fooled by the AI hype, and there is an awful lot of hype around. Who on the panel agrees or disagrees with me?
So that's a question on the sustainability of mathematics professors. Luis, this is a question for Luis.
Well, so that's what let me tell you what I tell my students, and I'll use polite language because I'm in public. I say that mathematics is the ultimate nonsense detector. That means we're going to be employed for a long time.
All right, that's good.
Well, I mean, it's true what you said, but the implication can be exactly the opposite, right? If there is an insatiable desire to, to get, then it might work the other way around, like everything else in this nonlinear situation. But I agree with you. Mathematics is very, very important. And right now, we reach the situation when equations which we could not have solved even a few years back, or for example, like many years back when I was, say, at Los Alamos, we were trying to build a planetary system for climate prediction, and that's where all this reduction to, say, from Navier-Stokes to Kamasa-Holm equations and things like that. Now we can try to attempt doing this. Fundamentals are very important, but at the same time, we should not be restricting ourselves to exactly solvable problem, by which I not necessarily mean solutions which can be written like e to the alpha t and that sort of thing, but even like solutions which can be found by solving PDEs through finite grids, for instance. But we should go further. We should go further. We should attack turbulence. We should go to scales which are much lower than normal and that sort of thing. Yeah.
Okay, I think we have time for one more question.
Thank you very much. Hello. I'm Sebastian. I'm from Zenith Labs at Alda HQ years ago. I wanted to say I had the honor of being brought up by a family of French resistance, even righteous among the nations, I think it's called. And growing up, I heard so many stories about World War II and so on, and I thought, obviously, World War III will never happen now that we have the internet, globalization, we can learn so much and not have the fear of the unknown and so on. But yet, here we are at a time when mutually assured destruction doesn't seem to be such a deterrent anymore. So I wanted to ask then, do you think AI can be used to ensure we have a future, in the sense of would AI, if we fast forward past the technical challenges, and it was a very interesting presentation by Steve this morning about these resistors that might make it more like a brain. Do you think the AI will end up being just the most knowledgeable person in the world and thus still only human in a way? Or can it become beyond human, without any of our faults, our egos, our selfishness, and so on, to be kind of the responsible adult?
Maybe I can answer a slightly different question, which is, I think the future of humanity is going to be perhaps less reliant on AI and more reliant on events like the ADIA Lab event that we're attending today. We need more of this.
All right, we have run out of time. Thank you so much. It has been a pleasure. Very exciting answers and participants, and I hope you had a good time, and now it's time for even a better opportunity to network and have some fun together. Thank you.
Thank you everyone. So I would like to invite you all to the atrium to attend our poster fair, where you'll have the opportunity to network, to talk, to get to see some of the researchers' work, and we continue to discuss sustainability in AI and how everything works together on the biggest issues of all time. And thank you everyone for joining us today, and see you later. Thank you.